Hi, I'm Sumit Jaiswal. Currently, I'm doing MTech degree at the Department of EC in the Indian Institute of Science, Bangalore. Today, I'll be presenting my project work. That the title of the project is Millimeter Wave Network Optimization for Full Duplex System. I'm currently working jointly with Professor Rajesh Sundaresan on this project. Uh, so the motivation behind it is the growth of wireless data uses has been phenomenal in India and growing at the rate of 25% annually. So to sustain this growth, the technology is shifting from lower frequency band to the higher frequency band. That is millimeter wave, who's having the range of spectrum from 20 to 300 gigahertz to achieve the data rates in Gbps. But the main challenges for millimeter wave is the high propagation loss. So we need a multi-hop network so that the signal can transmit through easier to the existing base station. The deployment density will be high and the infrastructure cost will also be high. So my goal is for the suppose there are key sources having k weights W1 to WK. I'll be maximizing the sum of the weighted flow over the number of relays as well as the relay location. So our scope and focus are the following: formulate and demonstrate the hardness of the optimization problem, devise a good heuristic for identifying relay locations, devise a good heuristic for identifying the time sharing policy, identify a numerical method to solve the optimization heuristics. So this is the network under analysis in which there are key sources and there is a block back box which is containing the number and location of the relays, and there is a existing base station that is T. I'll be trying to find the weighted flow from all the users, and I'll get it the sum of the weighted flow by applying the Ford Fulkerson algorithm. Evolutionary algorithm is an algorithm which is inspired by the theory of evolution, and this is also inspired by the different mechanisms present in the nature, such as mutation, recombination, and selection. Differential evolution is one of the type of evolutionary algorithm which help us to find the minimum value of a derivative free function. But this is not guarantee for a global minimum. But yeah, as I keep on increasing the number of iteration, then in the successive iteration, the value, the objective function approaches to the global minimum. So relay placement algorithm, I'll be generating n number of points that is lying in an area of 2 kilometer by 2 kilometer, whose coordinates will vary between -1 to 1. And then I'll be generating a capacity matrix by calculating the distance between the pair of nodes. And then I'll be getting a time sharing matrix S by using the Sinkla's theorem and by using the concept of gradient descent algorithm, we will be getting the optimal S matrix that can give the maximum weighted flow. And the effective capacity matrix I'll be getting by element wise multiplication between the elements of the capacity matrix C and the time sharing matrix S. Then I will be applying Ford Fulkerson algorithm to find the sum of the weighted flow so that I can get the optimal time sharing matrix S. And also I'll be using differential evolution algorithm to find the relay locations uh, to get the maximum weighted flow. And I'll also be finding the maximum number of relays uh, that we need to get the optimal uh, capacity flow or optimal net weighted flow through the entire network. And this R max should be that value so that the one additional relay will not improves the rate flow up to a particular amount of uh, flow. So once the additional relay will not improve the capacity uh, of the given threshold, then we will just consider that is the number of maximum relay that can provide the maximum maximum throughput, maximum net weighted flow through the network. So here I have taken a 2 kilometer by 2 kilometer area in which the existing base station is at origin, and the three users, user 1, 2, 3, I have located in the region and I have fixed it. Then I have used and found the location of four relays, that is relay 1, 2, 3, 4, which is located so that it will located at the position so that it should provide the maximum net weighted flow. So this is the network that got, and it at any point of time which user and is transferring the data from the source to the sink through which relays, and this is the graph that is showing the number of relays versus the net weighted flow. As I'll keep on increasing the number of relays, then the net weighted flow is keep on increasing. And also, if I'll keep on increasing the number of iteration in the differential evolution, then the net weighted flow is keep on increasing. And the maximum net weighted flow I got for 100 iteration is 64.75 Mbps. And for 150 iteration, I got 83.14 Mbps. The conclusion is this project can help deployment engineer to deploy base station optimally to reduce infrastructure cost and provide high speed data rate and good quality of service to the users. Thank you.